Okay, so everyone has the course material now, right? Does anyone not have the course material? Show of hands. Good, okay. I'll shut that down. Let's go. Okay, so everyone has an editor, everyone has Python, right? Yes. Okay, good. Then we'll start with this. So pick a folder where you want to keep the files for this course and create a new file which is called, I don't know, hello1.py in this folder and save it. And in this file, write this. And these quotation marks are the straight quotation marks. They're not tilted. I don't know why the compiler did this now. So save it as a file. That's called something.py or hello1.py or something.
So we are not using Spider now. Or?
Yeah, we can use Spider.
Okay.
Yeah. I've done all the examples general, so you can work with Spider or without Spider, with an ID or without an ID. And if you do it with an ID, you click the run button at the top to run the program. And if you do it in the terminal, you write it like this. So you have some command prompt, and then you write Python or Python 3, and then a space and the file name.
Daniel, what's the difference between single quotes and double quotes? Single quotes.
We'll get to that. Så att fungera datorn.
Jag är inte server och jag har inget internet.
Ja, okej.
Eller morsan ska du få jättestort ord.
Can you show the next slide?
So, has everyone saved the file? Cool. Okay, keep working until you save the file that contains. I'll actually show this slide instead. That contains this print hello world. So once everyone gotten into the habit of opening a new file, writing some code, saving it and running it, will accelerate a bit in going through the examples. But for now, just make sure that you know how to start a new file, write some code in it, save it and run it. And if you have any problems, tell me and we'll help you.
Okay.
Okay, now.
Okay, everyone should have remembered the syntax by now. So those who have an ID, like Spider, you click run, or I think it's the green triangle up top.
Okay.
And those who do not have an ID and are writing it in directly in the terminal, write Python space and the file name. And you have to be in the folder where you saved it. So did everyone get this to print hello world? Okay, good. So I wait until the excessive typing stops, and then maybe everyone is done.
How can I stop the program if it is going to the easy to do?
Hold Control C. Control C.
Control C.
Yeah.
Oh,
Creating an infinite loop and trying to print hello world. That's a new.
I mean, that's possible to make loop with one character print.
I don't know. That's first.
I think that's really impressive.
It's Java. Shows good promise to become a real programmer. Okay. So show of hands. Who has not gotten this to print hello world? Okay, one person. Then in the meantime, I've always thought that this hello world stuff is kind of bland. So we'll do a more interesting hello world. Yes, save a new file. And now we'll do some magic, and you will just have to take my word for what it does for now. We will go through what each and every line of this program does in the coming lectures. So after the first afternoon session, this program will make total sense to you. But for now, I just wanted to write it to make sure that everyone has the packages they need, that everyone has the Python running as it should do, and that it works okay. And also you'll see something cool. So just copy this code, and then as the day goes on, we'll talk about how it works and why it works. So we won't care about how this actually works now. Take it as black magic for a few hours.
This distribution on a console, is it built in with some editors there? Or?
Yes,
Like Spider.
Spider is the built-in ID.
Okay, so Spider is rather good.
It's the most MATLAB like of there. I just use text editor because I don't know. It feels better to just use text editors to me. So you can start Spider through the Anaconda Navigator if you want to do that. But I just like to run everything in the console.
The situation. I must go.
Okay.
Now I know it.
Okay. Kan du säga till sen när det är ungefär en kvart kvar? Ja,
Okej,
jag ser inte klockan bra härifrån. Ja, så säger vi
Bara detalj, men single och double.
Jo, det finns
Båda fungerar som
men största anledningen är att man kan använda kod innan på strängarna. Jag kommer att nämna lite. Is it working?
Well, none of these are installed, so I suppose some people might not have that.
Can you check to which Python the pip is installed? Crispin.
Yes, that should not be a problem. Do it, make it so.
If it's an ID, you should be able to bring up a terminal within the ID and then write pip install there, and then you don't have to check bindings. So,
No such thing as that's a good start.
Yeah.
It's internal Python console, never mind.
So is it double quotation?
yes. Yeah, so you can use double or single quotes. It doesn't matter. And I just changed between the two examples so that you would have two examples with both of them.
But many people use instead of NP.
Yeah, I just,
Because many start to use the NP, so you try use the NP, yeah.
I started using N because I use NumPy so much that just writing one extra character save time.
Yeah, but
So much.
yeah.
It's actually working better. I started using it just because it's faster.
Yes.
So you could write now.
Okay, so everyone should get this. I don't know if they changed how the random number generator worked between Python versions. So some of you might get a different number, but if you have the same version of random number generator as me, you should get exactly this number.
That's not really random.
No, that's how random number generators work. They're not random.
Like by the name,
Yeah.
like EPR, you know.
No, but I mean, that's a super interesting topic, actually, that random numbers are not random, but it's true. So,
But not such.
Where can I find the result? Where?
so here, how you say?
Say yes.
And then you go into the console, the CMD. So if you go to hold the Windows key and press R on the keyboard, the Windows and R. No, that's the thing with the Windows. And then you go to the folder where you save the with CD director.
Are you using Spider?
I also.
For me, I have the
So on this system, NumPy is actually installed, but IPython doesn't seem to find the package. Is it using 2.7 or something?
You always only have this.
Yeah, I might be using 2.7. It depends on how it was installed first.
Okay. Even if you have to.
Yeah, but wait, is that Anaconda?
No, Spider.
Is it Spider from Anaconda?
No, it isn't.
So,
And I don't see what virtual control is to the I.
So if you just go into the console and type Python -- version, what does that say? Oh, what?
So the problem. Yeah, it's 2.7.
Yeah, try Python 3, that's version. Yeah, I.
Could you back to the previous? Okay, yeah.
Type Python 3. If you type Python, then you don't have the 3.
Yes, yes. So actually I can show you this.
Because I
So
can't find it.
there are, okay, that's, so let's see it like this. So here, so for everyone who is using the console and not using an IDE, I'm just going to show you now. If you do this, you see what version the Python command is bound to. And if you have it like me, if you do this, and then you put a 3 at the end, you get another version. So you might have to do this when you run your programs. And if you do not use Anaconda and Spider in Anaconda, then you have to make sure that you're using the correct version. And it's the same with pip, because if I do pip, I get this. And if I do pip 3, or so let me do this. So, but it can also be like this. This can be bound to 3.7, depending on how your system was installed. So I have changed to another system, and it's different here. And there it says that this is bound to 3.7. So if you want to check what you're actually doing, you need to do this. Well, I thought most people would install Anaconda, but those who didn't need to check that you're using the correct version. And if you want to check what packages you have installed, and this is, again, if you are not using Spider in Anaconda, you do PIP, and then you write freeze. And you're going to get a list of all the packages you have. And somewhere, hopefully you don't have this large a list on your computer, you should just have like a few packages. But somewhere on here, there should be NumPy. Here.
Do you have any experience as installing pip on Windows? Because there is no pip on Windows.
Yes, I installed. But it's strange, I could just want to.
Yes. Download the Bootstrap Python file from pip website and run it from the Python distribution that you're going to bind it to. Yes, that's Jesus, my brain. Okay.
What do you mean? Okay, now I have a program. Well, why is that? Okay. This random the seed is the seed.
Daniel, how did you get this?
I mean, the figure goes.
Yeah,
If you do use
but
the
I type this to get to this. But this is only if you've installed Python and then trying to run it from the
How
console.
these packages later.
Ah, okay. Yeah, because that is my name. So many.
Weet je wel een heikel? Maar dat is zo. Maar dat is Python. Så man kör 14 där, så där den är spider. Den är det där är inte spider.
Also nicht so, dass er eine Funktion hat. Das ist einfach Konvention, die schreibst du also wenn das so funktioniert wie bei dem anderen.
Det är något som är skumt. Det verkar inte finnas större vägen heller. Det är någonting konstigt. Man måste göra så. Man kan ta det här på kameran.
Dann weiß der automatisch.
Det kan ut där också. Det skriver så mycket.
Genau.
Så där kan du att vi kan skriva. Eller så. Jag kan ju köra det också.
Yeah, I have this, yes. Just
Brandfire.
yes, but I have to. Now you can write.
Because now I find that
Yes, yeah, one can check and navigate, Anaconda navigate. Yeah, Anaconda navigate.
Okay,
You can search for package.
now we've done some bug fixing. Everyone should be along. Let's move it on. Okay, now, everyone knows how to create files, save files, run files, and it's working. Now let's go into actually learning how to program the language. So first, I need to give you a short introduction to how Python works and why it works like that. So let's just talk a bit about what Python is. So it's an interpreted, object-oriented, high-level programming language. And then it has dynamic typing and dynamic binding. And we'll talk about all these four things just very briefly. So interpreted means that any code is run through an interpreter that executes the program directly. So, for example, let's say that you have a program where you first delete a file, and then after that, try to do something that doesn't work. Then it literally will go through line by line and execute everything, and the file will be deleted, even though the line after didn't work. So be aware of this, that it will actually, it's not like C or any other compilated programming language, where it will actually compile it into a functioning ball of code, and then you run it. So here it will actually go through every line of the code before it even knows that it works. However, it checks some things before it runs. So it checks that you have your syntax correct. It checks that you haven't done any weird spelling mistakes in functions and things like this. So, and most languages can actually be implemented both with compilers and interpreters. So, any questions about the interpreted part?
Yeah.
Yeah.
Is it possible to get a compiled version, executable?
Yes. Short answer, yes, and we only have time for short answer. And this is also why you can actually, if you write Python and not provide a file name, you will get into a console where you can write Python live, exactly like MATLAB, thanks to it being an interpreted language. Okay, object-oriented. The language supports, in quotation mark, objects. And these objects contains both data and code. And that's the important part. So data is called attributes and code is called methods, but we'll see a lot of examples where we execute code that is bound to certain data types. And this is thanks to it all being objects. And also, this idea of everything being an object really comes into play with a lot of the simplicity of Python, that you don't need to declare types, for example. And we'll get more into that later. High level. We are as far away from machine code as humanly possible, almost. So we don't need to use pointers, we don't need to allocate memory, we don't need to do direct typing, but the language is strongly typed. I'll talk about that more on the next slide. And why it is strongly typed means that basically every object has a type and every object knows its own type. So if you have an integer saved somewhere, it knows it's an integer and it has all the code that pertains to integers in itself, inside itself. So it's strongly typed, but you don't have to tell Python that it is an integer. So that means that here, when I put a to 5, it just becomes an integer. You don't need to tell Python that this is supposed to be an int and not a float. Types are not declared. That's what this is. But they can be. There are fringe cases. Since Python 3, you can actually declare types in a way.
If you change the type, is that a problem?
What?
If the type changes during the calculation, is that a problem?
No. So it's just actually this is where names come in, because names refer to an object, and names are not typed. So this you don't really need to care about that much. It's just to complete the terminology. So here, A is the name of an object of type integer. So there's a difference. You can assign A to an object of type float. It doesn't care. You just changed what the name points to, what the name of that object is. So that's why you can just change the type however you would like, because you're just saying, well, this object does not have this name anymore. It has this name instead. So when you're changing types like this, you're not actually, you're not actually changing some internal data. You're just destroying this object because it doesn't have a name anymore, and you're creating an entire new object and just giving it a new name.
In MATLAB, you have to, for instance, you have a number and you want to use it as a character in another way, then you have to do some kind of change to string or change to number or something like that. Yes, it's also the case here.
Yeah, so Python has,
It will know whether it's a number or
yeah, it knows exactly. So if you send A into any function, it can just look at what is A, because every object knows its own type. So that's really good. But it's also a bit dangerous, which we'll see when we go through how functions work, because you're going to see some interesting things there. We don't have to declare types. Yeah, and also the functions in Python are super smart. So if you call, you try to convert a string to a float, it knows that, okay, this is a string and I want to go to a float, and it actually parses the string and creates a float. So it does it all automatically when you just try to rebind it. In the correct, you just have to call like float and parentheses and it does it. We'll do more of that later. Anyway, basic syntax. So Python works on indentation. So the best way to explain this that I figured out was that indentation decides what block your code belongs. So indentation can be a tab or a number of spaces, like 4 spaces is standard. And I recommend you to use 4 spaces as the indentation, because I've run into trouble where I've used tabs in some files and spaces in others, and then everything breaks. So pick one and stick to it. Yes.
I get code from other people using other editors. Do you know any editor that can automatically change?
Yes.
Because that would be so convenient.
Emacs stuff.
Yeah.
Indent region.
so you get all your spaces as tabs. So
Yeah, it replaces a tab with 4 spaces. But you can do it with a console command too. You can actually, like, if you're using Linux or a Unix system, you can actually just type a command and then a Python file, and it will just change all the tabs to spaces, or vice versa.
Could you maybe mail me that later?
Yes, I can give you that command. Okay, and you can write code live in the interpreter. We talked about that. And each row is executed in sequence. But the important thing is this indentation block thing. So let's talk about what I call by a block. So a block is a region of code that belongs to some identifier. So here, this is how you define functions, for example. We'll talk a lot more about this later, but just believe me that this is how you define a function. So what this indentation means is that row 3 belongs to function 1. So whenever function 1 is executed, it knows that, okay, it's row 3 that's going to run. You don't need any brackets or anything like that. It goes by indentation. And then if you put another row here, which also has an indentation, it will take that one too, until the indentation stops once. So you really you can't have like this and then start an indentation and hope the code belongs to function 1. The indentation has to be sequential. So for an if statement, it would look like this. So this belongs to this if statement. If this if statement is set to run, it will run this line. Indentation. And of course, you can have blocks that belong to blocks. So here we have 2 indentations, here we have 1. So that means that all of this code belongs to this identifier, but this line belongs to this one. So it's recursive. You stack indentation on top of each other, and everything with more indentation belongs to the block above.
can you use brackets too?
No.
It's so much easier if you see brackets. And,
Yeah, I know, but
okay.
Python done this for clarity, I think. I come from C myself, so I was a bit it broke my heart a bit when I didn't get to use brackets, but now I've gotten used to it, and it actually feels pretty good.
I think the purpose was to break with the strategy that you have in C occasionally, where you have if some condition column and then you write it in the same one because there is only one line that you wanted to write anyway, and
Yeah.
it's just and some people invent with tabs, some with spaces, and the code just looks horrible no matter where you go. And so in this case, they probably just went along the lines of saying, okay, this is part of the language, deal with it.
Yes.
Your code's gonna look similar, gonna look the same everywhere.
Yeah. So you can't
maybe that was
just
the idea.
use brackets to do some, because really, if you use brackets, you could put this and this and this all in one line. I mean, that's not readable, but this is, you can read this pretty nicely. So it's sort of forcing you to create readable code. Yeah. Okay, so I'm just going to mention scope really, really quickly, because this, we may have questions about this, because I've talked about this block thing, then we have something called the scope. And what scope is, it's the region of code, or we can say the lines of code, where information exists. So the scope of, for example, A here, are all these lines, because you can access A, or actually the scope of A is 2, 3, and 4, because everyone on these lines, you can access A. So the scope of A, where it exists, is these lines. But since B was defined inside this function, the scope of B is just line 3. You cannot access B outside this. So when I talk about scope, I talk about where you can access that piece of information in the code. Yes.
But now in row 4, you try to access P, or is this wrong?
Yes, this will error.
Okay.
This will not work because B is not accessible in this scope.
But the defined function, the variables in there are not independent. So if I define A before, A is available inside
Yes.
the function. Okay, I didn't know that.
So like this. This will work, but this will not. And that's just because when we talk about things later, the term scope may come up. So I just want to cover what it means. That is the region of code where information exists. And also, some people think that scope is analogous to indentation, but it's not. So scope is literally where it exists. And indentation does not decide where variables can be accessed in the code. Not always. In this case, it does. And in, I don't know, 70% of cases it does, but not in all cases. So, and also scope can be dynamic. Scope can change depending on what happens in the program. So you can have super weird configurations of the scope of a variable. And it's also important when you try to find errors in your code. So.
I have a question. When you have this def, you only know that this stuff is finished when you go to the line. I mean, you don't, in MATLAB you have an end.
Yeah.
When you know this is the end of the stuff or the loop or
Yeah.
so on. So here you don't have any end.
No, the
It should
end.
be aligned all the time, otherwise it's not in.
Yes.
Okay.
So the end here is the stop of the indentation. When the indentation stops, that's the end of the definition of what belongs to function 1.
So if you have a space, for example, here, if you have a space before the B, would it work? Because it's not aligned with function then.
It would, if you have this indentation somewhere else in the code, it would say indentation does not work, and then the program would not even run.
The point is, it doesn't matter how many spaces you use as indentation, so it does not have to align with function. It can be only 2 spaces, it can be 15 spaces, that doesn't matter. It just needs to be the same amount of spaces to be in the same scope.
Yeah.
Oh.
So sorry, to be in the same block.
Yeah.
The same scope.
And
I think that was the confusion just now.
Oh, yes, I do have indentation.
Okay.
Yes, now I see
Yes.
that it is indentation.
So yeah, you get indentation error. Okay, so what we're going to go through after the coffee break will be all of these keywords. So these are the basic keywords in Python. And we're going to have an example for each and every one of them, except for a few, which we'll take after lunch. But this is what we will spend the morning on going through these keywords, how they work, what they do, and some examples. And just to show you sort of how code looks, this is how you do a comment. You write a hashtag. This is how you write a multi-line comment. You write 3 single quotes and then end with 3 single quotes. This is a string, but this is also a string. This is an integer, this is a float. You call functions with parentheses. That's sort of universal in Python. If you want to call a function or method, you use parentheses. If you want to assign something, you simply assign it. This will give you an error since you have not defined C, but this will work. Basic syntax, just some, so you get a feel for what comment looks like and strings and everything. And before we get into the keywords, I think I have, how many minutes left? 10 minutes? 10 minutes. So before we get into even how the keywords work, we need to go through the basic data types of Python. So what are the basic building blocks that the program will be made out of? So we have integers, floats, strings, booleans. That's logical statements, true and false. Then we have the weird ones that are not usually a part of the regular programming language. Tuple, list, dictionary, and set. And I'll skip sets because I don't think it's super relevant, and you can look it up if you need to yourself because they're pretty similar.
Spelling error, is it
It's a spelling Jesus. Yes, it's a spelling error. It's a dictionary with a C, not a dictionary. Okay. I think I fixed that last time. I was equally surprised when I did this lecture for a PhD student. Okay, so tuple, list, dictionary, and these are the 3 that we will cover how they work, because all of these, I mean, you're all familiar with them. So. Okay, let's try to do a quick string example before we go to coffee break. So start a new file, save it as, I don't know, strings.py, and define q as a string, and then print q.
Daniel, how do you clean when you have other variables in the stuff, how do you clean it from the...
You don't remove variables. They always live around. They're picked up at some point by the automatic garbage collection of Python.
Okay, that's I don't think that. So you're using Spider?
What do you mean?
Yes, Spider on Anaconda.
Okay.
I had run. I mean, I had a Python file before.
Yeah.
So I just, to see if it was running, I run it. So I have now some variables in the stuff that I cannot remove.
So you need to restart the engine, I think it's called, or something. I don't use Spider, so I don't really know how it works. You should just run the script again, and it should remove everything. And this is also very, yeah. So now let's, what you usually want to do with strings is format them in some way. So now we will go through the 3 ways of formatting. So if you just add another string variable, so another variable does a string somewhere, And then we will go through the 3 ways to format. So the first way to format is called old style formatting, I think, which is where you do this percent sign and then S for saying that we're going to put the string here. And then you put the parentheses after the percent sign. Thank you. A percent sign after the string, and then you type what's going to go into the string inside parentheses. And then you print this to see that it actually works. And that's called old style formatting.
For the older ones, yes.
No, it was just this in Python 2.
Oh, yeah, it's Python 3. I need to see
Right,
that.
yeah.
Yes.
I don't see, what is the sign before the A in brackets? It's also percent?
Here,
No,
there,
yeah, this one.
that's a percent sign, yeah.
And it's the same percent sign as that one?
Yeah, it's just different fonts. Because I use
For
different,
clarity.
Okay.
yeah. For clarity or confusion, you pick. Yes.
How important is spacing in between?
Not important. I just, because it looks nicer. And then this example is called new style formatting. And here it comes, this I talked about that objects actually have both data attributes and code in them. So here, this thing is an object of type string. So this is a string object, and it comes with a bunch of code. Or one of these functions that comes along with it is format. So if you write dot format, you're actually accessing code that's supposed to work with strings. So dot format, and then you put what you're going to format into the string here as the arguments to the function. And to show where it ends up in the string, you put these curly brackets.
It's just different syntaxes, or is it some?
There are differences, but mostly it's different syntax.
The advantage of the second version is that you can actually use so you can use the normal language. You don't have to extend the language by using this weird percent sign, but you can actually use a normal function. So you can use all the magic that you later on learn with Python that you can use with functions like deferring and whatever. You do all that.
Okay, then if you define A as an integer, then what is happening?
Then it doesn't work. This doesn't work because here you tell it explicitly that I should be getting a string. So then it doesn't work. It will say type error or something. Here, we haven't defined a type. So that means here it will just try to convert whatever you put into it into a string. So it will automatically say, well, okay, I got an integer, so I will try to convert the integer to a string, and then I will put it in. So this automatically converts anything it gets into strings. And the last one is called F formatting, and it works if you have Python 3.6 or above. I think I tested in 3.5 and it didn't work. I don't, maybe it worked in 3.5. But I'm going to use this from now and then in the slides. So if I type this formatting and you don't have 3.6 or above, change it to one of these two. Because I've switched to doing this a while ago, because it's the advantage that I found with this is that it's a lot less text to write. Because here you write this thing and then format, and then you have to write them in the in an order here, and you have to state the order in the string. With F formatting, what you do is you write an F before the string, then you write the string, and then everything inside these curly brackets will be executed as Python code. So you could even write equations here. Don't do that, but you can. But you can also call functions here, for example. So that's a really useful thing that I found, was that you can, if you want to call a function inside the curly bracket, it works. It just interprets everything between here as Python code. So when I put a here, it knows to get a and put it in the string.
Yes. Has this special meaning only when it gets before a string, or could I mess it up by defining it as a variable earlier? Or?
No, it doesn't look for a variable. This
it has a special meaning.
yeah, it's a special meaning. So it just, if it finds f and a string, it knows that, okay, now I'm going to do f type formatting.
Why did I invite to form? What's wrong? Invite
Why F does it?
I guess f stands for formatting.
because I have here, here, and then
This is just less code. It's just, and it's also super obvious where it's going to end up, which is nice. Here, if you have like 10 of these, you go like, which argument is what? So it can become a bit more convoluted if you use this.
Okay, okay, fine. Okay, so I have only 3.5. I'm good.
Okay, yes. So those who do not have 3.6, just skip this one.
Very good question.
Actually, yeah.
Because I'm not used to this.
No.
Not version.
Oh,
really?
Okay. So
Oh, I have
let's try to finish this before coffee
Are they
break.
Mac and curly braces?
How the bloody hell are you trying to curly braces on Mac?
Yeah,
How do you try curly braces on Mac? Okay.
yes.
And then
I have problem with this one.
Okay.
Okay.
So
Yes. I have one. I always have a problem.
now we will try to input 2 variables and try to do a bit of formatting and more formatting for these.
Too quick, and now time is for.
No, okay.
Can you switch to?
Yes. So we'll do this after coffee break then. We'll dive into how to actually properly format stuff after the coffee break.
I have
15 minutes.
this column.
Yes.
Oh.
Yeah, exactly.
So 15 minutes coffee break.
There should be now coffee and something more outside. And tea, of course.
Jo, men
Jag blir lite konfunderad på apostroferna här. Men det ser ut som så början ja, enkel apostrof. Men sen jag börjar fundera varför en apostrof sen. Jag har en apostrof. Det får man till att
säga också att det är en del på och så måste man gå tillbaka till sliden. Men alltså gå igenom sliden och bara skriva.
jag bullar också. Ja, lite. Vi kommer se om man lyckas.
Jajamän. Som sagt, du har alla slides. Så det är bara att gå igenom dem.
Och så vet jag vad.
Ja,
Det är bara att gå igenom.
just
Jag snackar gärna mer.
this invitation is extremely dangerous.
Yeah.
Yeah, you know.
One has to get used to it.
Yes,
If you're going to use it, you have to get used to it.
No.
Indentation.
Yeah, because just one indentation completely mess up.
Yes.
Robert, I have
Serious shit.
need to.
Serious shit.
I messed up my entire computer. Everything working. Everything nice. No problem. I was setting up. I was sitting here talking to Daniel. Everything okay. Apt-get, install, git all. No errors. Absolutely normal command.
Yeah.
Then I did git checkout, git clone of this, and I got all the files.
So shall I provide that with
Woohoo! Some works perfectly. When I noticed my network manager didn't work. And when I started to double that, it didn't work. And when I eventually logged out of X, when X didn't start, my internet is gone.
borrow the
So I
one
cannot.
link from the bond?
Have you heard
Because
of
it should be the
anything
same.
like that? I
If it's the
never have
same,
any-
then yes.
I have many
Okay,
of
I will
things
go
in
check.
Linux,
But
this
it
is-
might be that that's the same case where we have this
So now I basically
tick one.
I think it's a small one on that too.
So I will go and check.
Who is the
Daniel?
And there is no sensible error messages. You don't see a broken install if you check the app. You don't see, but the internet interface is
Yeah, I
is
should have
wrong.
been here, but
And X
I don't.
doesn't start, and if you look at X or log, you don't find
No.
anything sensible.
But I would like to learn.
And I also tried to move the old kernel and the backup kernel and tried to move the recovery mode and exactly the same thing.
And there's learn myself.
Daniel? So I have Spider 3.7, but most command doesn't work.
Yes.
Ah, yeah, okay, thank you. Okay, thanks.
Why is it the way?
In your case, you change program to be
Ett ögonblick ska jag koppla in en ström här som strular.
Sådär.
De bilderna du visar, finns de också där? Jag tänkte, jag tittade lite snabbt på doktoranden. Det finns, det heter Programming Workshop. Jaha. Jag säger programmang. Hittar du någonting specifikt? Hittar du någonting? Vi kan behöva logga in med din användare. Jag ska skicka dig länken till var det ligger. Det är inne på, den heter inne på GitLab.tf så finns det program reflect course. Jag ska skicka det. där finns ju även, ska se här var inne på lectures, så heter den Python programming full day part 1. Om du bara laddar ner allt, om du går ut till Pro Course Material och så kan du ladda, då har du en inne i Git, så har du uppe till höger så finns det en knapp för att ladda ner allt. Då får du den i ja, och då kan du hitta det som sen innan när du laddar kan se till Python Programming full day och där är ju det där på sidan jag skulle ju ändå rekommendera att man eller ja, men det var struligt. Det var någonting som hade hänt i nätet. Vi hade ju förberett en som vi alla skulle kunna använda här inne då. Som inte skulle lastas av andra, men den funkade inte på morgonen. Fast det funkade igår. Och då visade det sig att det var någon switch någon annanstans som de hade bytt. Ja, det är sådär. Men nu ska det funka. Och som sagt, ja, du kanske ser mig, jag försöker vinka. Den är ju på live den här. Så låter väl den gå nu även. Jag börjar inte stoppa den. Men ljudet hörs också. Ja, det hör man. Frågan är om vi ska koppla in en sån där jävla eller om det duger med den här mikrofonen som är nu.
Aber du bist doch eigentlich nur ganz
Nee,
ich versuche mal zu verstehen, wie würde das jetzt in MATLAB aussehen, zu verstehen. Ja, also die zum Beispiel die Leitung, wie das in MATLAB beschrieben wurde. Und zu verstehen, wie das geht, kenne ich auch. Aber dann wäre S und F. S und F ist String. Prozent S.
ja, ich glaube,
Und dann Variable.
Nein,
Här var det kallt.
When did I write my paper?
Better than the reset of the cups later.
Imorgon har jag en minut. Och en mål. One after 30. Men you ever hear
Ja, men det var enda fixen. Om det inte kommer på något annat så får man Ja, det är klaver. Klaver Wikipedia-sida. Du ska läsa vad...
Vilket klass. Ja. Livselixir. It was nice to sit down for a few seconds. No one sitting here anyway, so.
Klassiska påskägget i Python. Det känner du till, va? Jag har inte sett det förut, så det måste du ha satt.
Okay, so we were finished with this one. Let's move on to you doing both strings and floats in the same line, and also talk about formatting multiple things into the same line, and also talk about how to decide what formatting to actually do. So now we have A is a string, B is a float, and the only thing we add here is this. In the first example, we had %f, and this means put a float in here. And then we just put the comma and the second variables that's supposed to go into the string.
But this F with the, what do you call it? It has a different meaning in the example before.
No. Yes, so this, since this is inside the string, it's just interpreted as %f. So the Python interpreter is really, really smart when it comes to these things. Usually it will sort all that out. And for the second example, now I've added some extra stuff to the curly brackets that you put here. So I put a 0, and then I put a colon and an S. And what this means, this indicates that the 0 indicates that you should take the first argument to format and put it here. So that this means that you should take A and put it here. And then the colon says, okay, now I'm going to tell you what you're going to get. And we put an S here to tell it that it's going to get a string. Just like we did here from the beginning. So this is a way to make sure that what goes in there is a string. In the previous example, if we would have, it would have taken anything. But now it's just going to take a string, and otherwise it's going to say, I'm not getting the right type. And then here we put the 1. That means get the second argument of format. We will do a colon and say, you're going to get a float. And it's the exactly same syntax in F formatting, just that instead of 0 and 1 to indicate what arguments to format, you actually put the variable names there.
Zero colon S.
Yeah.
What zero colon S means?
So this means that what's going in to this bracket is a string, and the 0 means that it's going to take the first argument of format.
0 is the first argument.
Yes. And 1 is the second argument, 2 is the third argument, and so on.
How about printing only first character?
Overcourse for this example.
Okay.
Yes.
Sometimes only you need only the limited number of the character that no matter what the claim that we have to pick up.
We can go through that later.
Yeah. Why is it necessary to declare that A is a string and B is a float? It wouldn't work with just A and B.
Here, this one. It would work, and we did it in the previous example. Here, we just had A,
right,
and it automatically converts it into a string. But one good thing about doing this is, first, we can be very specific on how we want it to format, and 2, we can probably find errors quicker. Because if we know that we have to put the string in here, and then it's not getting a string, then maybe we go, maybe something happened to A that shouldn't have happened.
Could we also use it in the end of that line, B colon S, to just convert it to a string? Or would that not work?
No, that would not work. Then it would say, I didn't get a string. But if you remove it, it will automatically try to convert it into a string. Anything it gets.
Okay.
And you can go even further with the meta application of code and do write float parentheses B here. So you convert B to float and then say that it's going to get the float. So it's a roundabout version of just putting B there. But that's how this formatting works, just to explain it. But that don't do that. It's just convoluted. Just use the automatic conversion function.
Could you please show the old version once more?
Yeah, this one. And then we're going to extend this example one more time, and then we're going to see also why it's really helpful to specify formatting. Especially, so I've designed these examples to be especially useful to scientists, because a lot of you want to print stuff, and a lot of you want to save text into files that's correctly formatted.
Is the random number the real number that because I printed out this random number and this given 3.1 something like that.
Yeah.
They syntax error.
Huh?
In your first example, you put a random number. So I
Yes.
put a random number instead of B.
Yeah. Okay.
Then it doesn't work.
You may be passing it to NumPy array, so you need to pick out the first element of the NumPy array. Where is it?
Yeah, the R is here.
Yeah. You probably need to do this. Let's see. Probably need to do. Oh, how do you get square brackets? Like this? No, I don't know.
This one.
Yeah, and then put a 0.
0.
And yeah, and try running it now. See if it works. And I can't explain how that works until this afternoon.
Okay, let me try. Oh, it works.
Yeah. Magic. Black magic.
So that means that, okay, then the specify it is a kind of real number, then we have to say 0.
Yeah, so no, that's just because from random you actually get a data structure that's saved in C. So when you do the 0, you're actually getting the data from the data structure in C.
So the random number is not a number. It's
No,
a kind of a
data structure.
sequence.
Yeah. That's specifics. This afternoon. That's way too specific. Okay. Now we're going to go into why this is actually powerful. So now we can just add a few dots and numbers here. So if we do .5 here, .1 here, and .2 here, and just look at the output, and then maybe someone can decipher and tell me what this means from the output. And if you already know that cheating, you don't get to answer.
Okay. I don't need it.
Is there a limit on accuracy of all the floating? So, I mean, how many digits can you actually use?
Exactly. So it's
no, not for printing. I mean, for calculation.
Oh, Python native is 64-bit float. So it's 64-bit float. So it's a mantissa of how many bits?
10 to 18.
Yeah. Okay. So it's and you can get up to 200 and what is it, 64-bit floats if you want to. So
you have to declare that, or
yeah, then we're going to go through that in this afternoon. That's it's hundreds on hundreds of, like it's 5,000 decimal points or something. You don't ever going to need that amount of data, but you can do it. So what this does, as was suggested, is it determines how many decimals are going to be printed. And if the number consists of more decimals than going to be printed, it actually rounds for you. So this tries to print 5 decimal places. This only has 3, so it puts 2 zeros there when it prints. Should do that. Did it do that for everyone?
Yes.
Okay. I was like, hope I didn't forget something. This one should round this to 3.1.
No.
What did it round it to?
Yes.
Yeah. And this should round it to 1.5 or 3.15. Yeah. So here you can actually define how you want things to print. And this is also, for example, how you define if you want to save numbers in a text format. You need to be able to write them with the correct precision. Otherwise, you're going to have problems. However, there are functions to already do that. So you don't usually need to write your own file writers. You can use some standard programs to do it. But if you do that, you write some text files and you specify too small amount of digits. You may get some serious errors when you try to load the data later, and then you don't have enough number precision to do your tries. So useful.
And it's the last example, it's even round to 2 digits.
Yes. So it does automatic rounding. It doesn't just chop off. So and I thought that this might be a bit over the top, but I'm going to say it anyway. And that's that this second part is really useful because, at least I found it to be useful, because you can use it as a template. So if you just remove this dot format here, because remember, this string was an object of type string. We called a method like code from that object, and that object is saved with the name v. So if you just print w without the dot format, it's just going to print this string. So try this, but then you do the formatting later on that object. So you do w dot format and the same thing, and see what it prints. So you don't have to do the formatting directly. You can do it afterwards. And that's, again, couples together with this idea that everything is an object. The object contains code, and you can call this code whenever you want to.
What is the B now?
Yeah, I changed. We're going to come through. So try this too and see what happens.
So you change
And remove the decimals from this. So make it an integer, because we're going to. I was just waiting until everyone typed it. So everyone finished typing this?
No.
Okay. So then also remove the decimals from b so that it's an integer, and we'll change from f to b. And here we will change from f to 03d. And this is just to show you that you can do this with pretty much anything. And I'll show you a link later to where we can find all this stuff, because I never remember it by myself. I always have the page up somewhere hidden on another desktop or something, and go and look through the formatting, because it's too many small rules to remember. Just look it up. I'll show you the link later. And ignore this line for now. We'll do this later. Just run this code without this line and see what it gives you. So any first guesses what this thing does and this thing does from the printing? If you just look at the output. Yes. So this means binary. So it actually prints 3 in binary code when you put B.
Okay. So B there is not the same as that B. Okay, now.
No. Yeah. So B means binary.
Okay.
And then maybe this D stands for some other system type, number system. Decimal. So D stands for decimal.
Is that one only Python 3.5?
Yeah, but you can write this with this one if you want to do the example too. So do dot format instead of F. It works.
Yeah, format I know.
So any guesses what this 03 does from the output?
drei Stellen mit Training.
AB. Is that format AB? This okay, number.
Wird wurde aufgeführt von drei Dezimalen.
Now I'm having everyone look at the output because I want you to actually run the program too.
I don't know if it works. Unknown format called V for object type float.
You need to remove this. The decimals here.
Yes, okay, yes, yes.
Okay, so any ideas about this?
What
Yeah,
not
you put
found?
everything on string.
What not found? Okay.
So
But OCD is the number of
what you should get here when you do this is you should get 0, 0, 0, 3.
Yes.
And that's because, or no, 0, 0,
0,
3. Yeah, so 2, 2, 2 zeros. Because what you're telling it here is that this is a decimal, so you represent it in the decimal system, which means the base 10 system. Here we did base 2. Represent it in base 10 and make sure it's a 3-digit number. And if it's a 1-digit number, put zeros in front of it.
Something wrong, but I have a 11 OCD.
And then for this, these rows,
Oh, yeah, that's right.
here,
Fine.
this is what I like to call a template. This string, when you print it just as it is, you get the string just as you wrote it. But it contains the, the formatting. So when you run this, you get the specific format. And you could run this again and again and again on W to get different formatting, depending on your input parameters. So this has essentially become a template for formatting something, just putting different numbers in there. So you don't have to redefine the string every time. You can just do format with new parameters, and then you format with new parameters again and again and again. And then the last line. So add this line again. E is a string, that's an object. It also contains code. And one of these functions that come with strings is the split function. So any takers on what this actually does from the output in the console?
Yeah.
Yeah.
I understand that it is.
So it finds all spaces because you said split and then you gave it a space. So it finds all spaces and it actually removes the space. And where it removed the space, it chops up the string and give you as a list of those substrings. So this would give you a list of this, and then is, and then string and the colon, and then it would give you this part, and then it would just give you the dash, and then it would give you this part.
Could you explain why the format AB?
Where?
Format AB, line 8, line 8, line 8.
Line 8. There. That's because we're doing the formatting later. Here we define the string,
Yes.
and it's just the string.
Yes.
And this is interpreted just as characters regularly.
Yes.
And this is not actually interpreted as some specific formatting language until we call the format. So until you call the format, this is just a string and these are just characters.
No, what the AB means.
It's the input parameters for format. So it's what's going to end up here and here. And if you would try to call format with 3, variables, it would say that there is no place to format it.
In this case, what A, B means?
The idea of the variables you want to.
Yeah, it's these two variables.
Two variables independently. Okay.
Okay, so any questions about strings? This is basically, I think it's pretty much all you need to know about strings for now, and the rest you can figure out yourself later. And all this formatting we've done here, it's actually, it's even called a format specification mini language. So it's a small programming language in itself. And you can go here. So if you go to Python docs, and then you go to string, and then you go to format specification mini language, you will find.
Scroll down in the document.
Yeah, or
You don't
scroll
have to
down.
type it out.
No, don't type this. It's but just so you know that it's in the Python 3 docs, and then you scroll down to this. Everything about this is there. How you format strings, how you format floats into strings, how you do this binary and decimal stuff, and it's all specified there. And then we had some questions about quotation marks. So there are some subtleties, but the most important part, I think, is that if you use double quotes, you can use single quotes within the string, and it's just interpreted as a character. You don't get an error. And if you do single quotes, you can use double quotes inside the string. That's the gist of it for the most simplest
You
reason.
can also C style escape double quotes in a double quote string.
Yes, which is
backslash escape.
which is where character escaping comes in.
Perfect. Thank you.
So these are some of the most used character escaping. If you want to backslash, you do backslash. If you want a single quote within a single quote string, you do backslash single quote. Because that creates a single quote. And so on. Here you have line feed, cartridge return, tab. Some of the most useful. And again, if you go to strings in the Python 3 library, all these character escapes will be there. And there's a whole bunch more. It's like one A4 page of character escapes.
What's the difference between line feed and carriage return?
Oh.
Carriage return by default actually does not go to the next line, but actually moves the cursor to the top, to the beginning of the current line.
Okay.
Yeah.
That's why you in Windows have \r\n, which is a return in line feed, whereas in Linux line feed actually also moves the cursor to the beginning of the line. The next line.
Yeah, that's
And
what I meant, because you
that
can
comes
use
from
the-
old style typing machines, like mechanical typing. Because there you had the paper here, then you actually had to go back and then go down one. So
If you just do a line feed, then you're actually continuing the line at the same position in the next line.
Oh,
yeah.
okay.
So
But in almost everywhere today, you just do this and it's fine. So,
N, okay.
yeah. Any questions about strings? Okay. Let's go on to talk a little bit about types and tuples. I just put these two together because they both start with T, and I like saying types and tuples. So start a new file, put something as a string, and then something as an integer, and just print their types. So do type, parentheses, and the variable. Just to, again, talk about this, that everything is an object. It knows its own type. Now we're going to look at what Python actually think about the types, what you get back if you check types. So I hope everyone here has Python 3 dot something. And if you don't have it, you don't get to answer this question. But what does it say when you do type S? Yeah, but what more does it say? Yes, it says class. And we're going to get back to this. I'm not going to have time to go through how classes actually work, but we're going to talk about them, why they're useful, what they're used for, when you need to use them. But what this tells you is that, okay, so what I'm checking S for, it's a string, but it's a class that's called string. And we'll get back to this, what a class is. But basically, a class is the way to define an object. That's how you define something that contains both data and code. And you can define your own classes. So whenever you type of something, it's going to tell you what the name of the class is. And now we'll go into the first data type that's specific to Python, which is the tuple. So when we define the string, we put quotation marks like this to define that everything inside is a string. Now we're going to do something similar. We're going to do t is equal to, and then 2 parentheses, and just our string and our integer. And then print the type of this and see what it tells you.
Okay.
So everyone should get class tuple. And that's because what you just created is the data type tuple. If you just write parentheses and then put a bunch of objects there, it will create a tuple, which is a data structure that contains a number of objects. So this is just, and those who are used to other programming languages that just has very rigid arrays and things like C and Fortran might have been surprised that it didn't complain that S is a string and I is an integer. So we have a tuple with 2 different kinds of entities in it. And that's again, the idea behind Python is that everything is an object. It doesn't care if the object is a string or an integer. Tuple is just a collection of objects. So whatever you put in there, it will say, okay, now I have this object.
So you should, so answer should be tuple?
Yes.
No.
Class tuple.
Class.
What does it say?
Just. Okay, I know.
Yes. Okay.
No.
Okay. And now, the universal way of accessing data structures in Python is the square brackets, or universal. It's the standard way. Yeah. So if we want to get at what's in this tuple, we use square brackets. And tuple is an ordered data structure. That means it knows what order you put the objects in it. So to get the objects back, you need to give it the index. So here we do t, square brackets, and 0, which says, take the first thing and give it back to me. And what you should get is the string. If you put the string as the first element.
You get the string back, you don't get the class of the string back or something.
Yes, you get the string back. So before I talk about more about these collections of data structures, we need to jump to another example. Has everyone got like, are there any questions about tuples so far? And this example? Okay. Now, start a new file, and we're going to look at lists, which is another data structure of Python. And I have to go through this first, because then we're going to talk about differences between lists and tuples. So now, instead of parentheses, we use square brackets. And if you try to print these two, here, it should just print the list with the square brackets and all the objects.
Is it L or 1?
L.
Okay.
Why I should have changed that font. Yes. I hope I haven't used L somewhere else.
Yeah, this is not a good idea.
Yeah.
Or not use single character variable names.
Yes, that I really hate it.
Yeah. Yeah. I'll update it until next version.
Yeah.
When you design 350 slides, you start not caring about what variable names you use. Anyway, so again here we have integers and characters or strings, I mean, in the same data structure. So it doesn't care about what type the objects are, as long as it gets a collection of objects. It will create a list. And instead of parentheses, we use square brackets. And then this should type class list. And this should just print the list.
What is the difference between tuple and this list?
We'll talk about that soon.
Could you quickly show the previous slide?
This one.
Okay.
Yeah. And you access lists in the same way. We'll talk a lot more about that later. So now we're going to look at one of the methods that comes with lists. So again, list is an object in C. It has, or in Python, it has it has code with it, and one of these functions is the append function. So try to do l.append, and then we give it an integer, and look what you get. And from the name and the result of the print, it should be pretty obvious what it does. And what's more, this shows you that the list is a dynamic object. You can add elements to it or objects to it, and you can remove objects from it. So it's dynamically allocated.
One question. Yes, if I would now have a list where I always, after every loop, I add something and have a long list. Yeah. Would this be like in MATLAB that it always copies the complete list, or will it really physically just add it?
It will physically just add it.
Yeah. So I mean,
so
you shouldn't reallocate matrix.
You can pre-allocate it.
Then what is the point of reallocating if you just physically add it? Because in MATLAB, that's the problem. If you don't reallocate it, then he's recopying it and it's like fine. But if it's reallocated, then you put it in, replace it.
So we'll look a bit about that later. I actually have done some timing examples where we look at pre-allocation and appending and look at the speed difference in Python. And we'll talk a bit about how that works.
So this dot append, this is kind of an object class or something. A class property or something.
It's an method.
Yeah.
So the terminology is that you have an object, and the object contains data, and the data is called attributes. Yeah. It's the object's attributes. So, and then the object also contains code, actual like code, and that code is called methods. So this is a list is a class in Python, and the class contains methods, and one of the methods is a function. So it defines exactly how you should add another element into list, and then it does it.
That's pretty much the same thing as for a string. The string class contains the format function or method.
That was exactly what I was thinking.
It's exactly same thing, yes.
And as everything in Python is classes, you can do this with everything, which is super powerful. And we'll go a bit into that later. So now, the difference between tuples and lists. I think there are more differences, but the most important one is that tuple is immutable while the list is mutable.
What does mean?
Immutable means that it can't be changed. It's fixed. Once you've defined it, that's the way it is, and you can never change it.
So you can't add it.
Yeah. So for example, this thing will error. So if you define a tuple as these two numbers, and then you try to access the 0th element and set it to something, it will say, no, I'm unchangeable, you can't edit my contents.
Oh, we cannot edit at all.
Yeah. And that's
cannot change the value of this.
You cannot change the element at position 3. But
no,
sorry, at position 0, yes, right. But you can, if suppose the element at position 0 is a string, you can still call stuff to it like uppercase or something. It will still do that, but you can't change the tuple.
But we'll get into that because that has to do with pointers.
Okay, so if you say that T equal A and B, then you define A and B, then you can change A, means that automatically you change the first element of the T.
Yeah, but you can't change what the first element of T is.
Yeah. So if you want the number of constants that you can't change at all, you can use a tuple. But if you want something where you want to change the values, you can use a list.
Well,
that's the difference.
Yeah, and you can append and you can do so. That's also why. So when we talk about what functions return later, we may get into tuple discussion if you want to. But there are really
it works. Good. So.
Yeah, really good reasons why tuple exists.
So if you want to do, you have to do the T equal A and 6. Then the second line is that A equals 3, and the third line is T.
Yeah, and then it works.
Yeah.
Yes.
Then you can change
so
that string.
You can change. So if T is a string, exactly as Robert said, you can change the internal workings of that string. But you cannot change that the first element is this string. Yes.
We actually was wrong. Because strings are immutable.
Oh yeah, okay. Yes.
Bad example.
Yes.
Sorry.
List.
First, exactly.
Yes. If the first element is a list, then I was not supposed to get into this now. We started talking about something I wasn't supposed to talk about. Bottom line is, this is immutable. You can't do this. Okay, and then we have to talk about deep copies, but we'll do that after lunch. So when you copy stuff, how this assignment actually works, if it, how it actually copies the data. So we'll talk more about that later. Now, to go back to your list example, and we'll talk about the last data type of Python that I'm going to go through, which is the correctly spelled dictionary. So go back to the list example where you had all this stuff. And then instead of parentheses or square brackets, we do curly braces or curly brackets. Måsvingar. Seagull wings. I don't know. And then we write a string and a colon and an object. And that's how this always works. String, colon, object. And don't do these lines for now. We'll talk about these two lines first. Lines 6 and 7. So if anyone here has worked with databases before, there is something called a key value database. And that's basically what this is. You have a value and you give it a key. And that key is the unique identifier of this value. And this is how this works. And so if you remember, the list and the tuple was ordered data structure. That means you had to know the order to know what element you were accessing. So to access element A, you had to know if A was the first or the second or third element in that data structure. Dictionaries are not ordered in the same way. They are ordered, but only in specific cases. We'll start talking about them as not being ordered at all. So to access an element, you need the key to that element. It's not made to be ordered in the same way as a list where you have to know what order they were put there in. So here, instead of saying that I want the first element, you say I want the data with key none. Did everyone get that explanation, or was there too much other talking?
Can you repeat it shortly?
Okay.
Well, I still do not know the dictionary. What's the difference from a dictionary from the ordinary array?
So, okay, from the beginning, there was too much other talking. A dictionary, instead of saving the data in an ordered fashion, where you have to know the index of the object, here you give each object a key, and the key is a string. So to get an object, you give it the key instead of the index. And here, when we initialize D, we put the object 5 with the key none. So this is the string identifier for 5, the 5 element.
Okay, so I did. Okay, so I did just 5 element of the string.
It's not basically like hash in Perl.
Yes.
That was super specific, but yes.
I think the usual common world example for that is actually the analog is a telephone book.
Yeah.
So you have the relation between name and phone number, and they're very specific. So if you can, this is a super fast way of accessing such a dictionary. That's why it's called dictionary.
Yeah.
Well, yeah.
Actually, dictionary is probably the better.
Yes, it is, but phone book is a real world example of it.
Yeah.
I mean.
So because I mean, if you want to tell them to look up your number in the telephone book, you don't say look at row 852,003.
On page 5.
Yeah. you say, well, look at my name, and then they take your name and get your number. And this is the same way. So if you print B, you will get a printout of the key and the value. And then here, if you add these 3 lines, this changes an object in the dictionary. So here, first we access the object. Again, square brackets is sort of the way to access data structures in Python. So we do the square brackets and then the key. And then we change the value to 0.
But the key has to be already defined, or can you?
Yes. Otherwise, it will say key doesn't exist, and you will get an error.
So line 6 sets the value of keyword num to 5.
Yes.
And line 9 changes that value to 0.
Yes.
And line 10 is defining a new one.
Yes. And again, Python doesn't care about what type things are. They just take objects. Okay. So here we define a new key that's called list, and then we set it to the actual list that we had up there. So if you print the dictionary now, you should get a printout where you see a key that's called num, and then a 0, and then you should see a key that's called list, and then it should actually put your list there.
Unless you read that as a 1 instead of
Yes.
But in line 10, you define the key called list.
Yes.
What's the difference between line 6 and line 10?
Yeah.
This initializes the data structure. This initializes the dictionary. So it creates the variable, it creates the dictionary.
So, but if the dictionary already exists, you don't need the brackets up there. You can use the square brackets.
Yes.
And if you use the square bracket in line 6, you get an error because it isn't defined.
Yes.
Yeah.
And also, so this basically does the same thing as this append. You actually create a whole new entry in your data structure because list didn't exist before. So when you try to assign something to list, it knows, oh, you're trying to put something new into the dictionary, and it does that. Yes.
Line 6, if I forget this one, is then will Python think it should do a list or create a list, or does it complain?
So if you would do this without doing this,
yeah,
it would say D doesn't exist.
Okay. Yeah.
Because here you're actually accessing D and trying to assign something you access to it.
Well, still I do not understand five in line 6. Is that
So it's just the object. I could have put an 3.4 here, or I could have put a string here, or I could have put whatever.
Why need that things in that case?
But you define a database with a key, and then you put the value for it.
Yes.
You populate the database with something. So that could be a variable where it could be
one. Actually, I looked at some of the.
Because our line 11, when I extended, this file completely disappear from the list, from the D.
But
Yeah, because you replace the 5 by 0.
yes, here.
Okay. I see.
I would like to point out in line 10. So the difference between the syntax in line 6 and the syntax in line 9 and 10 is that in line 6 you're actually creating a new dictionary with those predefined keys and values. So the key is num and the value is 5. If, however, in line 10 you would do the similar thing and write D equals curly brace, what have you, colon, whatever, then it would create a new dictionary and override all the work that you had done before.
Yeah. So if we do this, and then I do, okay, live programming. A is equal to dictionary. What is A? A is an empty dictionary. I can do this. Oh, it's a dict, which is short for dictionary. So if I do
Interesting. That if I put the real
and then I print A. Now I did the exact same thing. It has a key that's A, and it has the value that's for A. And if I do like this, instead I set the key, I create a new dict. So this initializes a new dictionary and binds it to the name A. And I put 3.14. And then I print A. What do I get? I get a new dictionary with the key B and the value 3.14 because I overrode it with a new dictionary. So this creates a dictionary while this accesses it.
Question that now when I put instead of 0, I put 3.1, then this 3.1 comes after this list.
Yeah, it's so there is an order.
Yeah, because,
because
5 is integer, and I put instead of okay.
Yeah.
So it says that now if I put 3.1, then it says that num and the list. Then now the first list is coming, and the num is coming. Is that?
Yes. Yeah. So dictionaries are not meant to be used as ordered objects. You're not really supposed to use the order of the elements. That's why you have keys. So here you have to know the order. Here it's supposed that you don't have to know the order. You shouldn't care about the order. You should just care about the keys. But there is an order, and it's good to know it in certain cases, but don't care about that for now.
Yeah, there is a lot of
caveat
there as well from 5 to 3.6, and that they are actually ordered as predicted.
Yeah. So anyway, so now, because you will probably come across this yourself sometime, I just want to show this. So we talked about how everything is classes and it says class float and stuff. So now we're going to do, so this is a bit of a circle argument here, but it's a fun example to show you. So this, you don't have to type this, I'm just going to show you. This defines a new class. So if I write class A and then don't care about what this does, this just defines a new class. And then if I do type of A, it's class type. So why is that? Well, you've just defined a new type. So yeah, you defined a new data type in Python. So when you create a class, you've defined a new data type. So if you try to check the type of a class, it says it's of class type. Roundabout argument. But what came first, chicken and egg, the type of the class? But just to tell you that this is how it works, so you don't get all super surprised if you somehow see like class type. Like what's that? Well, you actually, it's a type, new data type.
You get the same, by the way, if you actually have a look at the type of curly brace, open curly, not curly brace, but if you have a look at the type of string, str is the type of string, and that actually is the type of string. Yeah. So you get the same thing.
Yeah. And then, of course, you have instances. So when we did the brackets for doing a list, and when we did the curly braces for doing a dictionary, we created an instance of that class. So here we created an instance of our new class, and if we check the type of that, it says, well, it's of type A. And it also says where it comes from, because the native Python types, it doesn't have to tell you it comes from Python, it's in Python. But when you do it yourself, it says, well, you defined a new type in this function, and it's called A. So you can sort of trace back where the definition of that data type was done and look at it. This is just fringe knowledge. You may never need it. You may super need it. It depends on the use case. It's just good to know.
What is the dictionary update?
Oh, dictionary updates function.
You can use that. Okay. You can use the dictionary update if you have two dictionaries and you want to merge them.
Yeah.
So you have a dictionary A with the keys A and B, and you have a dictionary with the keys C and D. If you call dictionary.update, it actually puts them together, and the result is a dictionary A, B, C, D.
Oh, okay, I see. Yeah. Good.
Daniel,
yes.
When do you put semicolon? Because in MATLAB you have to put this dot comma all the time, otherwise it's printing in the. But here it seems that you
never have to.
Some semicolon and some not. When do you?
No. Oh yeah. So we're going to talk about that now. So in MATLAB, you have to end the line with a semicolon, otherwise it prints it out. You don't need to indicate that you're ending the line here or something like that. But we use colons instead. So not the semicolon, the one with the comma, but the regular colon, and we use that to indicate the end of these types of statements. So we use it to indicate the end of function definitions, the end of for loops, the end of if statements, the end of while loops, and all these sort of programmer standard program flow types things. I didn't know the word for that.
Control flow.
Control flow, thank you. I even wrote it in the section. So, okay. So start a new file and let's do our first program control flow example. So now we've done with the data types. Now we've done all the data type stuff. You know, lists and tuples and dictionaries, and strings and floats, yada yada. Now we're going into keywords. So the first keyword is for. So now we're going to do a for loop. And for those who do not have 3.6, use another formatting style, because I used it F formatting here. So. And then once you've written this, we'll talk a bit about how the syntax of this works and what all the elements are. Okay, now everyone should have a for loop, or be really close to one. So let's talk about the syntax. So first, you start with writing the keyword for. Then it knows, okay, the rest is going to define the for loop. The next thing that comes is the name of the variable that's going to receive the value that you're iterating over. So in this case, I is the thing that is going to assign different values to. Then the in keyword says, okay, now I'm going to give you the thing that you can iterate over. So it gives you an iterable. So anything that's an iterable, it's something that contains, can contain several objects. So it's just a data structure that can be iterated over. So lists are iterables, tuples are iterables, dictionaries are also iterables if you do some stuff with it. And then all the other data types are iterables. Files are iterables. Then you iterate through each line of the file. So anything that has multiple objects and you can go through them one-on-one is an iterable. So then you give it that. And here we gave it something called range 10. And what this range function does, it's native to Python. It creates a list of integers 0, 2, and not including 10. So when you print it, you should get hello world number 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And you shouldn't get 10. And then we end with a colon. And that signifies that, okay, we're done with the for loop statement. Now start writing the code for this for loop. So what for does, it's, okay, it takes this iterable, it gets the first value, and then it assigns it to I. And then it runs this code. Then it takes the second value of this, assigns it to I, and runs the code. Like a regular for loop. Any questions about the syntax?
My Python has syntax is error.
Did you use this?
Yes.
Do you have 3.6?
3.5.
Yeah, then you can't use F formatting. You have to use
yeah.
dot format.
Okay. Yeah. That's this quite this syntax.
Yeah.
If you want to have a different range, like if you want to iterate from 10 to 20, it's
Yeah, range. So range can take 3 arguments. It takes the start value, the end value, and the step, actually. Yeah. So you could do 10, 20, 2, and it would go 10, 12, 14, 16, 18, and not 20.
Separated by comma, or
Yes.
we can use an example.
Yes, just separated by comma. And actually, so this range is really useful when you just want to iterate through integers. But of course, you can iterate through other stuff. Everything that's an iterable, you can iterate. And it will be assigned to whatever name you put here, which is really, really, really different from other programming languages. And we'll look at an example on how that works. Now,
what is that supposed to give now? Number 1, 2, 3, 4, 5, or
yeah,
because mine gives number I, or number I.
Did you remember this F here?
Yes, I did.
Do you have 3.5?
No, 3.7.
Okay, now I need to look. That's weird. Yeah, so it's actually that was really poorly visible from the back. This is curly brackets. Okay.
But it wouldn't work with a dictionary because you don't have the sequence there.
Yes, exactly. But there is a function or a method for dictionaries that actually sets them in an order and lets you iterate over it. And that's why I said that there is an order there, but it's not really there. So you can create a dictionary to an iterable, but then you can't be super sure about the order because it's not built to do that.
And this one now counts from 0 to 9. So it means if you have an array, the first element is element number 0, always.
Yeah.
Because in some languages it's 1, and some languages 0.
Yeah. So this is zero index. Python is a zero index language. And we saw that in this example too. When we did this. No, where was it? Yeah, this thing. Here, it's zero index. So 0 is the first element.
Oh, yeah, that's right.
Okay, so now we will go into some weird stuff just to get it out of the way. So Python has something called dynamic binding, and it has very high level syntax, which means that if you define a tuple like this, for example, where you put the 5 or whatever 6.9 here, so you have a tuple, and then you try to assign 2 variables like this to A. Python is smart enough to know that you want to take the first element of A and put it in B, and take the second element of A and put it in C. So it's smart enough to actually take out the values here and assign them to the variables. And this super confuses people in the beginning.
Python is smart enough, but people is not smart enough to understand this.
I had so much trouble getting this to work in the beginning. But it turns out it's super useful.
Well, what is it that you're saying? So if you, for instance, give B the value 3 and C the value 8, then A would be 3, 8 after the line 2.
No, it's the other way around. So it assigns things here to what's there. So it always assigns from right to left.
Yeah.
So if I would switch it around, then that would happen. But this way, it takes B and gives it this value, and C and gives it this value.
Wow.
Okay, the other way around works as well.
Yes, it should work. The other way around.
So these are normal parentheses? Or?
Yeah, these are parentheses. And remember when I said, now we get into the bit spooky X-Files part. Remember when I said here that it takes this name and it assigns it to the item that we take from this iterable. That means that we're actually doing an equal sign somewhere. We're assigning I to that value. So here we're assigning I to first 0 in that comes from this. And then we're assigning I to 1. So that means that we can use this in a for loop. And then it looks like this. So if we have a list, that's the first element of the list is a tuple, and the second element of the list is a tuple. We can write A, comma B here, because then it will say, okay, we're iterating through the list. We take the first element of the list, that's a tuple, and then we assign it to whatever is here. And since this works, this works. This will seem super strange in the beginning, but just edit your example to do this and see what it does and see that it works. And you are going to see this everywhere if you look at someone else's Python code. So don't become super confused what this means. And there are even built-in Python functions that does this for you, which are super useful. So enumerate is one of those examples, or one of those functions. So I urge you to look up like enumerate, range, and zip by yourself. If you want to, I can do a live example in the console now with enumerate. Do you want to do that? Or should we just skip ahead and keep going, because we need to have time to do everything today? Okay.
Should finish this.
Yeah.
Once you
yeah. So
start
first,
to talk.
Yeah. First, finish this and see that it actually works, and then you have a file on your computer where you've done it, and you can go back and look at it if you want to do that.
What? You want to see that?
Lens. Well, because why the lens? Okay, now I understand this. So it must be integer. This must be
No, that should be the list. Yeah, D4 and then a colon.
Yeah, but this because if I do it in this list and here, then
it doesn't need to be integer, but it has to be the right amount of. There's
a column, okay.
And then this is 4 elements, and you only have 2 variables.
I don't know that. Yeah, syntax error still.
It's syntax. Oh wait, the colon is on the wrong place. If you go to the colon should be. Okay.
So the list, the type of whatever your variable you use, that can then change because it's assigned to whatever you.
Yes. So it just changes, and it's exactly the same as we saw before. It's just names that get assigned to new stuff, new objects. I shouldn't use the word stuff.
With the different line comes.
Yeah.
A is the first line and B the second line.
No, A is this element. So here it's 3, 1 and 2. A is 1, B is 2, and then the next iteration, A will be 3 and B will be 4. All right. Okay. Let's move on. I needed to take this out because this is used everywhere. And enumerate actually does this for you. So if you have a list, let's say you have a list of 3 strings. So you have a list of just 3 words. But then you want to assign an index to each word. So instead of doing like, oh, I is equal to 0, and then we do I is equal to I plus 1, like you usually do when you do a counter, you just use enumerate instead. And then you use this syntax. And then you get, in the first element, you get the counter, and in the second element, you actually get the word. So enumerate is like a super compact, nice way to do counters in loops. And it uses this syntax. And this is why it works. So, okay.
Vänta.
Yes.
Jag har syntax fel. Från A, komma B. In L.
Har du koll?
Ja.
Okay. Now I just, and the next slide is just to show, like I said, you can iterate through dictionaries. So don't copy this example. I just want to show you. But if you do .items, items is the method for dictionaries to create it into something that you can iterate over. And then again, you use the same syntax. You get the key in the first variable and the value in the second variable. Then you iterate over the key and the value. And this items creates an order for it. So it's a way to iterate over a dictionary if you want to. Just to tell you.
Om jag hade skrivit, if I had written for A in L, would that be an error in the previous example?
No, then A would be the tuple.
Okay.
So if you would have written just A here,
yeah.
A would be this tuple. It wouldn't know to extract the variables from it.
Yeah.
Yes. Okay, so let's do the next keyword, while. Simple while example. Since we did 4, I guess pretty much everyone gets this example. The interesting part here is to look at the output and look what the final value of A that is actually printed is. And again, if you don't have 3.6, change the F formatting to something else.
This works as I expect.
Yeah. And that's because, so while, here it just takes a Boolean, and then or a Boolean expression, I should say. So, and it evaluates this expression every loop. So it comes here, evaluates the expression. If it's true, execute this. And then it does that again and again until this evaluates as false. And it evaluates as false when A is equal to 4. So you will never print this when A is equal to 4. Then it will just jump over it and continue. And that's how a while loop in Python works. Any questions about while loops?
Yeah, it's easy to make the infinite loop.
Yes. Don't write while true. That's, well, you can. There's actually good uses to write while true, but don't start doing that.
Yeah, this is what today does.
Yeah. Okay, so the output should be this. That while example was a bit boring, so let's do a cool one instead. just take the same code and let's edit it a bit. So now, after lunch, we will go through what these 2 lines actually mean and do. For now, take my word for it and take it as black magic. But add these 2 lines, and then instead of adding a +1 to A every time, change it to this line. And then we extend the Boolean statement here in a while. By the way, does everyone know what a Boolean is? Okay, good. I didn't even think about asking that. Sorry. So I've added some black magic to these examples just because it's really boring to just print the plain old native stuff. To get to use some random numbers is a bit more fun. And we'll talk about how NumPy and random actually works later.
Det försvann också för mig. Jag har i alla fall nät, så det finns så många lösningar.
So, has anyone gotten this to run?
Not yet.
No?
Not at all.
If you run it again, do you get the same result?
Of course not.
No. That's why it's a much more fun while example. So here we see another keyword, which is the AND keyword. So AND is the logical operator AND. So it takes a Boolean and a Boolean and does the AND logical operator on it.
So if both are true, it goes through the takes the next line.
Yes.
If one is not true, then it will jump out.
Yes. And then, so in Python, logical operators and OR are actually the words and OR. While in C, it's like double ampersand and double straight lines. And I think it's the same in MATLAB.
Just a question, what is the value range of the random numbers?
So just for this is just a normal distribution with 0 mean and 1 standard deviation. Yeah. And that's why I just picked these so that you would get a reasonable loop.
No, understand.
Why do you have to input? So you define A first, so you can go to Y, and then Y you have to define.
So this draws a new random value from the normal distribution. So you update the value of A. Otherwise, this would be an infinite loop, or it would never execute. So. Okay, so now you can. Oh, did everyone get this to work, by the way?
Yes. Not yet.
Okay.
If one random has n1, does it give a random number around 1? What was the...
It's just that you need one number. We'll talk more about that later.
What is the limit of a random number? If it were
no, this is a normal distribution. Okay.
So But Daniel, for this loop, you should have done A equals B. I mean, for the random number, then you get the random number, and then you can run it.
Yeah, you can do that too.
A.
Yeah, you can do that too.
Sounds so wrong that I don't
But then
get
it might
anything, any
error
thing.
if you happen to create 50 random numbers that doesn't exit the while loop.
I don't know why it doesn't.
And actually, there is a probability, even if it's like less than the number of atoms in the universe, that this might become an infinite loop. But, okay. So, just take the code, copy it into a new file, and let's start edit it a bit to get into what if-else statements does and how they work. So now, copy the old code, start a new file, and then change the while into this if statement.
I'm down there. Uh-huh. Uh-huh.
So if statements also like staple of any programming language. It works exactly as you would expect. You write if, and then you give it a Boolean. And if it's true, it does it, and if it's not, it executes the else statement. And you don't have to write the else statement. This is optional, but this time we wrote the else statement. I'm going to sit down for 2 seconds.
Yes, I have Python 3.6 and 3.7, and if I run this as Python 3.6, it works. If I do pip3 installed numpy, it says that it's installed.
So if you do pip -- version, what does it say that it's the pip is bound to?
It's probably 3.6 is my guess.
This is exactly what I've written a 4-document thing about how to make it so that the correct Python version is bound to the correct pip.
It's in this document.
Yeah, but I didn't send it out because it's too large for the average user. We can look at it later.
It's amazing that Python works so nothing else works.
Yeah.
But as soon as I need some graphics out of this.
That's weird. I still don't get. Okay, so here you might have to spam run the code a few times to get both answers. Because, as you might see, it generates a random number, then it checks, is it outside ±1? If it is, it prints the line number 6. And if it's not, if it's inside ±1, it says nothing weird to see here. So that's a regular old if statement. Any questions?
I think why too small threshold? Too large threshold, so that I should change to 0.5, otherwise it doesn't come.
Okay, so as I said, the if statement, you can write just the if statement. You don't have to write an else. Here we did if and then an else. But then you can also do, of course, an else if. So in Python, you write that with elif. You do elif. And I get the reason for this, because since else is a keyword and if is a keyword, you don't want to accidentally have people put spaces in between them and think they're doing something else than they're meant to be doing. So it makes sense that else if is a keyword that's spelled differently. So this basically says that go here, evaluate the Boolean. If it's true, execute this line, and then jump to them. If it's false, go to the next else if statement and check that. And if that's true, execute this and jump to them. And if this is also false, then do else.
What is the formal meaning of colon in Python?
It's usually the end of keyword statement that begins a new code block. So if you do a function that begins, so if you do define function, then you end the def keyword and begin a new code block. That's basically.
It's not a new code block. You are supposed to indent after that.
Yes.
Kind of.
Yeah.
Oh, yeah, there's no while sentence. Okay.
And yeah, so why this works is because, or why this prints that I'm positive, I'm pretty normal. That's because A is from a normal distribution. And first, it checks if it's outside 1 sigma. In other words, if it's not that normal. And if it's inside 1 sigma, it checks this statement. And then it just evaluates this if it's true, which means if it's positive. Did everyone get how this works? Okay, good. Then I don't have to do it. Okay, any questions so far? Good. Let's keep moving on. So now, I will have to talk a bit about data structure manipulations. Just to speed things along a bit, because I want us to do a proper practical task before we move on. So, actually, maybe I'll skip this. So, okay, we'll do NumPy after lunch. It takes too much time. Okay, so let's talk about this instead. Accessing elements in lists. So it's not really manipulation, it's just accessing. We'll talk about accessing elements. And more importantly, about how indexing works, and indexing syntax. So here we have a list that has a bunch of elements, bunch of integers. And we did the square brackets and then type the index before when we access. So 0 for element 0, 1 for element 1 for the second element. In Python, you can write ranges of elements in the accessing of a list. So if you want 1:3, you will access element 1 up until and not including 3. So this will get element 2 and 3.
One is not including, yeah? What did you say again?
So it's because it's 0 indexed.
Yeah.
So element 2 is actually indexed 1.
Okay.
Yes.
So
Okay.
if you
Yes.
sort 5.
Yes.
In this case.
Because I don't say element 0 in normal spoken English. So this is index 1 up until and not including index 3. Which means if you talk about lists in a one indexed way, it's elements 2 and 3. If you talk about it in a 0 indexed way, it's elements 1 and 2. And this colon operator, you can leave the first index here, and then it will just take from the start up until and not including index 3. So this would return
3, 4, and 5.
yes, 3, 4, and 5. So that makes sense. And this, in Python, -1, when you put negative indices, you count from the other way. So you count backwards. So if you just do -1, so if you remove the column, you actually get the last element. But since this says everything up until and not including the last element, this would return 4, 5, 6, 2, 1, 2, and not 3. Because you're going from 0 up until and not including the index that you put after the column. And then just column means all elements.
But if you only write print D, does it also give all integers?
Yes. So actually, something very important about this notation is that when you do these things, you're actually returning a copy of the list. So you're actually taking these 3 elements and returning a copy of the list. And that is why we also have to talk about, later in the afternoon, we'll have to talk about how copies work. So shallow copies and deep copies.
Too many values to unpack.
Huh?
Too many values to unpack. Too many values to unpack.
No, so
yes, I usually see.
Oh, okay, yeah.
I mix
this one.
No. This one. This part. This part we went to the append class. Yeah.
Try to do it with the list instead of 2.
A stupid question, how do you make a matrix? Because this is a vector, right?
Yeah.
How do you make a matrix?
So list in Python is the very, very basic like data type. So to make a matrix, you have to do a list of lists.
Oh, nice.
And this is like
I don't like this one.
Yeah. But no, push you. No, but seriously, that's why NumPy exists. Because in NumPy you can just create a matrix, and it's defined all the data.
Use MATLAB?
No, it's better to use NumPy. We'll talk about NumPy after lunch. So here we have defined the Python way of doing a matrix. We have a list, and then in each element is in itself a list. So this would be a 4-row matrix with 3 columns. And this is a bit weird of an example. If you want to try it, can you tell me what this will return without writing the example? It's like a...
Would it print out the matrix in the correct order?
Yes. If you just do print. So what do you think? It's a bit of a brain teaser.
You say that this language is easy readable?
Yes.
Very easy readable. What is B130 blah blah blah?
I show you this to show you how the syntax works. So this is not how you're supposed to handle data when you do science. This is not how you're supposed to do it.
You need to use NumPy.
Yes.
Yes. And NumPy is MATLAB.
No.
Yes.
NumPy is C written code that's wrapped in Python. It's very different. Okay, so whatever.
And NumPy will come back to normal language.
So first bracket. This one returns a copy of element 2 and 3. So it returns a list with this and this in it. Then you do 0. So that means you access the first element of that list. That means you get this one. And then you do this, which gets the first, all elements except the last one, which gets you 5 and 3. So just an example of how you can really convolute your indexing if you want to.
If you want only to have 1, 5, 5, and 2, what do you do? Because you
then,
said now it's working by kind of...
Yes. That's the horrible part about using lists to define matrices, and that is why I say you shouldn't do that. because you actually have to do something called list comprehension to get a column out. And that's that's how not matrices should work. So use NumPy, and we'll talk about NumPy after lunch.
I had an error message with this.
Really?
Yeah. Int object is not subscriptable.
No, but then you have not.
You should.
Will be identified or something. You have to forget.
Yeah.
So.
What time is it? How much time do you have? -1. No. Can't have it. Okay. Do we have time to go? Do you guys want to do list comprehension before lunch, or do we do it after lunch? After lunch. Okay. Lunch break.
Why should we start again?
Earlier than 1 o'clock. Yeah, 1 o'clock. Yeah, let's do 1 o'clock.
Yeah.
Yeah. Let's do 1 o'clock. Probably we should. Yeah. Anyway, now everyone's already on. I mean, it's.
Alltså,
Stoppa den här nu. Då kommer det bli en ny film sen.
vad